What's up, amigos? Today we have the aerodynamics of a rustic loaf of bread, and this loaf of bread, this is my loaf of bread that I often buy this one, and I bought it one day, and I took it to work to scan just so I could do this. And the reason why I wanted to do this is because on top, so it's like fairly rustic, and it's like a boat-looking kind of thing, but on top they have these cuts made into it when they put them into the oven, and then there's the bread then expands, and it makes these like little caverns and valleys. So I wanted to see how that channels the flow. And this Z plane going from the ground upwards shows the U magnitude, going from 0 to 27 meters per second. The free stream velocity is 20 meters per second. And we can see that the loaf of bread is very wakey. Down below, there's a huge wake. And then as we go higher, all these little crevices, they start to channel the flow a little bit. And then you start to get the big crevices, and they channel the flow a lot more, which then reduces the wake size a lot. So you can see the ridge at the top of the screen. This really divides the flow and pushes a lot of the flow down into the downstream, and we'll see that in the next video as well. And now we have the streamlines going around the loaf of bread, and we have the ground plane visible as well with the pressure plotted. So first of all, we can see that the pressure in front of the loaf of bread is quite high, as you'd expect. As the flow hits the front of the loaf of bread, it has to decelerate. That increases the pressure. Around the edges, when you have a lot of flow separation, the pressure drops a lot. Then the streamlines going over, they accelerate a lot over the front part. We can see what I was talking about in the other video, where the top ridge, like the ridge on the leftmost side, that the streamlines hit it, and then they sort of get channeled into it, and then they get pushed down a little bit into the rest of the wake. And then the other streamlines around the other ridges seem to follow really funky lines as well, and even roll up a lot into a big wake on the left half of the bread. And now these animated streamlines show again just how chaotic the flow is. The flow over the top of the bread accelerates quite a lot, so this bread is actually producing quite a bit of lift, which I suspected when I was taking it to work. I thought the bottom of this bread is very flat, where the top is very curved, so I think this is going to be producing lift. But the back half of the bread is very wakey, so the lift to drag ratio would be very poor, I think, for this. So let's see the simulation. Let me know what your favorite loaf of bread is. Is it one of these ones? Is it a baguette? What? And make sure to like and subscribe. And check out the Atmosphere Hawk. It makes your experiments and CFD validation 2 to 4% more accurate. Link in the description. Peace out, amigos.